I, Huzaiza Farheen, welcome you to Republic Tutorials. Get ready to expand your knowledge with this captivating study material. Hello and welcome to this video. In this video, we will be solving the three questions, that is question number 8, 9 and 10 of exercise 11.4. Coming to the 8th question, we have simplify 1 minus cos theta into 1 plus cos theta into 1 plus cot square theta. So, we need to write this expression in the simplest form. For that, if you observe the given question, it is 1 minus cos theta into 1 plus cos theta. This is actually in the form of a plus b into a minus b. So, we have the law that algebraic identity that a plus b into a minus b is equals to a square minus b square. So, if we consider this 1 as a and cos theta as b, a minus b into a plus b can be written as a square minus b square. So, a square is 1 square minus b square is cos square. Then we write this term as it is, that is 1 plus cot square theta. We have the trigonometric identity that sin square theta plus cos square theta is equals to 1. From this, we can calculate the value of 1 minus cos square theta. So, what did we do here? We transpose this cos square theta to the RHS. So, sin square theta is equals to 1 is there already in RHS. So, we are writing it here, plus cos square theta will become minus cos square theta. So, instead of 1 minus cos square theta, we can write it as sin square theta. And we have another identity, cosecant square theta minus cot square theta is equals to 1. So, when we transpose this cot square theta to the RHS, we get cosecant square theta left on the LHS is equals to 1 is there on the RHS, that will write first, and this minus cot square theta when transposed, it will become 1 plus cot square theta. So, the value of 1 plus cot square theta, what we got from this identity is cosecant square theta. So, 1 minus cos square theta, we got it as sin square theta. So, we write it here, and then 1 plus cot square theta we have got from this identity, that is cosecant square theta. We know that cosecant is the multiplicative inverse of sine. So, cosecant theta can be written as 1 by sin theta. So, sin square theta as it is into cosecant square theta can be written as 1 by sin square theta. We can cancel this and what we are left with is 1. So, the value of this expression is 1. Therefore, 1 minus cos theta into 1 plus cos theta into 1 plus cot square theta is equals to 1. Then, coming to the next question, we have the question is if secant theta plus tan theta value is p. If secant theta plus tan theta is equals to p, then what is the value of secant theta minus tan theta? So, if you can see, we have secant theta and tan theta. Here it is plus and here it is minus. So, what is given? Secant theta plus tan theta is equals to p. What do we need to find we need to find the value of secant theta minus tan theta. We know one of the identities of trigonometry, that is secant square theta minus tan square theta is equals to 1. Actually, this is in the form of a square minus b square. Anything which is in the form of a square minus b square can be written as a plus b into a minus b. So, what will be our a here? The a will be secant theta. This is a square means secant square theta minus b square is tan square theta. So, b will be tan. So, it is in the form of a square minus b square. So, it can be written as a plus b into a minus b. So, we can write this secant square theta minus tan square theta as secant theta plus tan theta, that is a plus b into secant theta minus tan theta a minus b, that is equals to 1. But we already have the value of secant theta plus tan theta as p. Let us substitute that. So, we get here p into secant theta minus tan theta is equals to p, and when we transpose this p to the RHS, we are left with secant theta minus tan theta on the LHS, and that is equals to 1. Here it is because p was multiplying with the entire expression. So, when we transpose it, it will go into the denominator, that is 1 upon p. So, this was very simple, right? Coming to the next question, here the next question is question number 10. If cosecant theta plus cot theta value is given as k, the value of cosecant theta plus cot theta is given as k. Listen carefully. Then we need to prove that cos theta is equals to k square minus 1 by k square plus 1. So, let us write what is given. So, given is cosecant theta plus cot theta is equals to k. Then what do we need to prove? Cos theta is equals to k square minus 1 by k square plus 1. This can be solved by taking RHS first. We will take the RHS and we will prove that LHS will be equal to cos theta. So, what is given in the RHS? K square minus 1 by k square plus 1. We know the value of k as cosecant theta plus cot theta. So, we can write this as cosecant theta plus cot theta whole square minus 1, k square, right. So, k square means cosecant theta plus cot theta whole square minus 1 by, here again we have k value as cosecant theta plus cot theta, k square it is. So, whole square plus as it is, and this is 1. Now, it is in the form of a plus b whole square, and this is also in the form of a plus b whole square. So, what is the expansion of a plus b whole square? We have it as a square plus 2ab plus b square. So, what is a here and what is b? So, if we take this, the a here will be cosecant theta, a will be cosecant theta and b will be cot theta. So, a square is nothing but cosecant square theta plus 2ab we have. So, 2 a value is cosecant theta into b value is cot theta plus b square is cot square theta. What is this? A square plus 2ab plus b square minus 1 as it is, that we have copied here. Now, in the denominator also we will be applying this same identity. So, cosecant square theta plus 2ab means 2 cosecant theta cot theta plus b square is cot square theta plus 1. Now, moving ahead, we have the identity that cosecant square theta minus cot square theta value is 1. From this, we can calculate the value of cosecant square theta. As you observe here in this question, we have cosecant square theta, I have highlighted it, right. So, cosecant square theta minus 1. So, from this we can calculate the value of it. So, cosecant square theta minus 1, if you bring this to LHS, then cosecant square theta minus 1 is equals to, we are transposing this cot square theta to the RHS. So, you will get cot square theta, that is cosecant square theta minus 1 value will be equal to cot square theta. And one more thing, from the same identity we can write cosecant square theta is equals to, this time we are transposing cot square theta to the RHS and we are not bringing this 1 back. Okay. So, 1 plus cot square theta. I repeat, cosecant square theta minus cot square theta value is 1. From this we can calculate the value of cosecant square theta as well. Also, we can calculate the value of cot square theta. In order to calculate the value of cosecant square theta, what we have done here, we transpose this minus cot square theta to the RHS. So, it will become 1 plus cot square theta. So, we have the value of cosecant square theta as 1 plus cot square theta, or you can say 1 plus cot square theta value will be equal to cosecant square theta. The second thing is, from the same identity we can calculate the value of cot square theta. So, how do we do that? Again, in this case, because minus cot square theta it is, right. So, we will transpose this to the RHS and we will bring this 1 to the LHS. So, cosecant square theta minus 1 is equals to cot square theta. as you can get this from this. Then if you observe this statement, cosecant square theta minus 1. So, cosecant square theta minus 1 value is cot square theta. We can replace the value of cosecant square theta minus 1, these two terms, with the cot square theta. So, instead of cosecant square theta minus 1, we are writing cot square theta, then plus 2 cosecant theta into cot theta as it is, plus cot square theta. This was already used, right? Then moving to the denominator, we have cosecant square theta as it is, then 2 cosecant theta into cot theta plus cot square theta plus 1. Cot square theta plus 1 is value is cosecant square theta. So, what did we do here? We just combined these two and wrote it as cot square theta. The only thing that we did in this step is, then cot square theta plus 1, we wrote it as cosecant square theta. From this identity, we have calculated it. Now, as we have x plus x is equals to 2x, so cot square theta plus cot square theta will be equal to 2 cot square theta plus this we are writing as it is, that is 2 cosecant theta into cot theta by cosecant square theta plus cosecant square theta will be 2 cosecant square theta plus this thing we are writing as it is, 2 cosecant theta into cot theta. Now, moving ahead, we have 2 cot square theta plus 2 cosecant theta cot theta. So, what do you find common in this? 2 is there in both the terms. So, we are taking 2 common. Here we have cot square and here we have cot theta. So, we can take 1 cot theta as common. So, 2 cot theta is taken as common. So, what is left out here? That is cot theta plus as it is. Then when we take 2 and cot theta as common, what is left here? Cosecant theta. Similarly, in the denominator we have 2 and 2 and here we have cosecant square theta and we have here cosecant theta. So, we can take 2 cosecant theta common. So, what is left here? 1 cosecant is left. Then what is left here? Cot is left. So, we will write cosecant theta here, cosecant is left and here cot theta is left. As you can see, cosecant theta plus cot theta, here also we have cosecant theta plus cot theta. Order does not matter, a plus b is equals to b plus a, right. So, we can cancel these two and 2 and 2 can also be cancelled. Now, we are left with cot theta by cosecant theta. We know the value of cot theta, that is cot theta can be written as cos theta by sin theta and cosecant theta can be written as 1 upon sin theta. So, let us write it. Cot theta we have written as cos theta by sin theta by 1 by sin theta. Then moving ahead, how do we write this? Cos theta by sin theta, numerator fraction we will write as it is, then we will write into sin, then whatever is there in the denominator we will write the reciprocal of it, sin theta by 1. 1 by sin theta was there, so we will write sin theta by 1. So, this sin theta is in the numerator and this sin theta is in the denominator. So, we can cancel these two. So, what are we left with? That is nothing but cos theta. This is the LHS that we were supposed to prove. Therefore, we have k square minus 1 by k square plus 1 value as cos theta. Thank you.